Why nobody has beaten Interstellar's black hole. There's a shot of a black hole that gets used in actual physics lectures, not a NASA simulation, not a textbook diagram. A shot from a Hollywood blockbuster. That should be strange to you. Movies fake things for a living. Somehow, this one didn't. And here's the part that really doesn't add up. It's been over a decade. CGI has gotten unbelievably more powerful since then. Render farms are faster, tools are better, budgets for big sci-fi movies haven't gone anywhere, and yet nobody has made a black hole that beats Gargantua. Not nobody has tried and failed, nobody has really tried at all. That's the actual mystery here. Not was Interstellar's black hole good, everyone already agrees on that. The real question is why. With more technology than Christopher Nolan ever had, nothing since has come close. And the answer isn't what you'd expect. Let's go back to before Interstellar, because you need to see what the bar actually was. If you grew up watching sci-fi before 2014, you know exactly what a movie black hole looked like. A swirling funnel, purple and blue, maybe some sparks, stuff getting sucked in like water down a drain. It looked cool. It looked dangerous. It also had almost nothing to do with what a black hole actually is. Nobody was lying to you on purpose. Nobody had a better option. A black hole doesn't look like anything, technically. It's not glowing, it's not swirling. It's just a region where light can't escape. Everything visually interesting about it is actually about the stuff around it. So for decades, filmmakers just designed a cool-looking void and moved on. It worked. Audiences bought it. There was no reason to do more. And to be fair, there wasn't much to copy from. Nobody had a photograph of a real black hole to reference. That didn't exist yet. Scientists had drawings, equations, theoretical models, but nothing you could point a camera at and say, make it look like that. So every earlier movie was essentially guessing, filling in a gap with whatever felt suitably terrifying and alien. It's not that the effects were lazy, it's that everyone was designing in the dark, in the most literal sense possible. Here's the strange part, though. Christopher Nolan wasn't satisfied with worked. When Interstellar was still in early development, Nolan had a decision to make that most directors never even consider. He could have used the drain vortex shorthand. Audiences were primed for it. Nobody would have complained. Instead, he brought in a theoretical physicist and basically said, show me what this would actually look like. That physicist was Kip Thorne, and this is where the story stops being about visual effects and starts being about a genuinely unsolved problem. Thorne wasn't hired to make suggestions. He handed the effects team real equations, Einstein's field equations, applied to a massive, rapidly spinning black hole, the kind of math that describes how light bends when it passes close enough to something with that much gravity. That's the part nobody had actually rendered before, not stylized it, rendered it correctly. And almost immediately, the visual effects team ran into a wall. If you calculate light bending around a black hole one ray at a time, which is how most rendering software works, you get flickering. Not a small flaw either. On an IMAX screen, the image would shimmer and strobe in a way that looked broken, not otherworldly. So they had to build something new. Instead of tracing individual light rays, they wrote code that tracked entire bundles of light at once, following how those bundles twisted and stretched around the black hole's gravity. It's called the double negative gravitational renderer, and the fact that a visual effects studio had to invent new rendering science just to make one shot work should tell you how far outside normal movie VFX this was. Here's where it gets interesting. That renderer didn't just make a great shot, it generated so much precise data about how light behaves near a spinning black hole that Thorne and the effects team turned around and published actual scientific papers from it, peer-reviewed, in a physics journal, because of a Hollywood movie. Sit with that for a second. Usually the direction goes the other way. Science informs fiction, fiction dramatizes the science. End of story. Here, the fiction accidentally became a source of new scientific insight. Nobody set out to do that. It just happened because they solved the problem correctly instead of solving it convincingly. But even this wasn't a straight path to perfectly accurate, and that's the part most people skip over. There's a glowing ring around Gargantua, an accretion disk of superheated material. In real physics, half of that disk would appear far brighter and bluer than the other half because of how fast the material moves and how that affects the light reaching you. Thorne knew this, the team modeled it, and then they deliberately removed it. Why would you build something scientifically accurate and then take the accuracy back out? Because it looked wrong to a human audience. Not inaccurate, wrong, confusing, lopsided, like a rendering glitch instead of a cosmic phenomenon. So they kept the physics that made the image feel real and simplified the physics that would have made it feel broken. That's not artists overriding scientists. That's artists and scientists agreeing on which kind of truth actually matters on screen. And that decision is probably why the image still holds up today. It wasn't chasing a trend. It wasn't built to look impressive by 2014 standards. It was built from a foundation that doesn't age, because gravity doesn't update itself the way rendering styles do. A stylized vortex looks like whatever decade it was made in. Gargantua just looks like a black hole. Now, here's the question you've probably been sitting with this whole time. If this actually worked, if it actually held up, why hasn't anyone else done it since? At first glance, you'd think it's a technology gap. It isn't. Studios today have rendering power double negative could only dream of in 2014. This isn't a "we can't" situation. It's a "we don't need to" situation. Interstellar's black hole wasn't a set piece. It was the engine of the entire story. Time dilation near Gargantua is the reason a few hours on one planet costs decades back on Earth. The physics isn't decoration, it's the plot. If Gargantua looked fake, the whole emotional core of the movie would have collapsed with it. Nolan needed the audience to believe it on an instinctive level because the story was asking them to feel the consequences of real general relativity. Most movies with black holes in them are not making that bet. The black hole is a backdrop, a threat, a visual flourish. Nobody's assembling a team of physicists and writing new rendering software for a shot that only needs to read as "dangerous space thing" for 20 seconds. That's the actual difference between something built to look cool and something built to look real. Cool just needs to hit in the moment. Real needs to survive scrutiny, and it needs an underlying reason for every visual choice, not just an appealing one. Here's the part that's easy to miss, though. You don't need to know any of this to feel it. Most people watching Gargantua for the first time couldn't explain gravitational lensing if you asked them. They don't know what a caustic is, they've never heard of the double negative gravitational renderer, and they still sense, almost instantly, that this black hole is different from every other one they've seen in a movie. Something about the consistency of it, the way the light bends the same way every time, the way the disk behaves like it's obeying a rule instead of following a mood board. That's what real physics gives you that artistic guessing can't. Not just accuracy, internal consistency that your brain picks up on even when your conscious mind isn't tracking the math. Think about how you can usually tell when a video game shadow is fake, even if you couldn't explain why. It's the same instinct. You're not running the calculations yourself. You're just noticing when something behaves like it's following a system versus when it's behaving like it's following a mood. So no, nobody has beaten Interstellar's black hole. Not because it's untouchable, and not because modern CGI fell short. It's because almost nobody since has needed to answer the same question Nolan and Thorne asked themselves. Not how do we make this look impressive, how do we make this look true? Until another story actually needs that answer, Gargantua isn't going anywhere.